"All models are wrong, but some are useful," is a quote by the statistician George Box. When he said it, he was probably referring to statistical models. So that's where I'll start too. Let's say that I was measuring all of your heights and seeing how that relates to your ages. This is a plot of roughly what I would assume the data to be like. So how do we make a model of this? Well, perhaps the simplest and maybe the most obvious way is to just draw a line that best approximates the data. But wait, did you catch that? It's an approximation, as in it's not exactly correct. Some of your heights will be above or below this line. Why is that? Well, it's because height and age don't actually have perfect correlations in reality. Our model, which was really simple, it was just a straight line, made the assumption that they were perfectly correlated. But what about genetics or diet? Those are also pretty big factors, right? The idea that every model makes assumptions that don't reflect reality precisely is present in other fields too, not just statistics. Take physics as an example. I'm sure most of you are familiar with Newton's second law, F equals ma. But even this law has some assumptions. Well, to see what assumptions he had, let's see how Newton derived the second law of motion. You can see it on screen here. It's a pretty simple calculus exercise where all you have to do is apply the quotient rule. But take a look at this first term. Newton assumed that the mass of a body stays constant with respect to time. Now, usually this is true, right? Your mass probably doesn't change just because you're moving. But what about particles moving at 90% of the speed of light, or 95% of the speed of light, or 99% of the speed of light? Einstein was the one who figured out that mass actually does change with respect to time. It's just so minuscule for our daily calculations that it's completely negligible. And just to jump on the hype train a little bit, I'll also comment on AI. Neural networks are trained to approximate some dataset. But again, they're not perfect approximators. Take large language models, for example. GPT can write pretty good poetry, but is it a correct model of our world? Maybe in some ways. But is it perfect? Definitely not.